Service dispatch, may I help you?
Jeff here. I'm clear. What's my next call?
Will you check with Mrs. Bowman at 35 Locust? This is a NoHeat call. Billy did a tune-up there 3 months ago, and she had a fuel delivery last week.
Roger that. Mrs. Bowman, 35 Locust Street. No heat. On my way.
It's a common call. You might even call it routine. But as an oil heat service technician, it can be your most challenging. Sure, you have the tools and the technical training, but to your customer, this is a major emergency, and it requires many other skills as well, like customer relations and real detective ability. Yes, you should think of yourself as a detective with a mystery to solve. You have witnesses, an incident scene, and clues. But the most important thing you have is your own systematic method for eliminating one possibility after another until you're left with the answer. The purpose of this program is to reinforce this kind of methodical approach and to encourage you to follow those procedures each and every time you respond to a service call. Experience has taught you what tools you'll need, and you've taken them with you to make the most efficient use of your time. You go to the back or side door because that usually gives closest access to the furnace and creates the least disturbance of the customer's home. You're a professional, and you greet the customer with a neat appearance, confidence, and assurance. Then, like every great detective, you ask the right questions and listen carefully. The customer reports that the heat seems to have gone off overnight and there is no hot water. You ask to see the thermostat. It's set for 72 degrees, but it's only reading 66 degrees. Because there is no heat and no hot water, you know that the problem is not with the thermostat, but you check it anyway. Being careful not to leave smudge marks on the wall when you remove the cover, you turn it back and forth to ensure correct mechanical operation before returning it to its original setting. You also look around for possible adjacent heat sources, like a TV or electric heater, and then ask the customer if anything that gets hot was located there recently. She says there wasn't. You make a mental note of the heat anticipator setting. You ask the customer whether she has heard any unusual noise, detected any odors, or seen any smoke. She reports she pressed the reset button twice before calling for service, and each time the burner came on, ran for a minute, and then shut off again. You listen carefully to her answers and advise her never to push the reset button more than once. Listening carefully can provide important clues. It also assures the customer of your concern for her problem. You ask if there have been any previous problems. The customer reports that her husband had to push the reset button 2 days before, but it seemed to run fine after he did that. On your way to the basement, you check the switch at the top of the stairs to make certain it's in the on position. It is, and you've eliminated one more possibility. In the basement, you first check the fuel tank gauge. There's plenty of fuel and no visible leaks. At the furnace, you notice from the service card that Billy, who performed the recent tune-up, had vacuumed the unit, replaced the nozzle, pump strainer, and filter, and performed a full combustion analysis, which indicated zero smoke, negative -0.02 draft over fire, and 84% combustion efficiency. Now you check around the unit for excess oil. You don't find oil, but you do find your first solid clue. There's a small amount of soot around the air tube. Unusual, since the unit had been tuned up so recently. At this point, let's review the steps you've taken so far. You brought your tools with you, saving valuable time. You showed consideration for the customer by using the back door and wiping your feet carefully. You asked questions and listened carefully to the customer to learn and to reinforce her confidence in you. You checked the simple things first, because that's the smart thing to do. Turning your attention to the burner, you notice that the light on the CAD cell relay is flashing every second. This indicates that while the control is powered, it's in the lockout mode. The flashing light tells you that the current problem is related to the burner, the fuel system, or primary control. This is reinforced by the burner starting immediately when the reset was pushed. If it hadn't started, you'd know to look for an electrical problem, a thermostat malfunction, or a control problem. The soot points to improper ignition. Your clues are beginning to accumulate. To continue your investigation, you check the voltage at the limit control. The only way to test for proper voltage is with a good test meter. You remove the cover from the limit control and check the voltage at terminals B1 and B2. The meter reads 113 volts. Since the control will function properly with a voltage input of 102 to 132 VAC, you have the correct voltage. The fact that the burner is off on safety confirms that the thermostat is not causing the problem, and leaving nothing to chance, you verify that the heat anticipator setting is properly matched to the control. Next, you remove the thermostat wires from the TT terminals to prevent damage to the thermostat and check that there are approximately 24 volts on the TT terminals. Install a jumper to simulate the thermostat calling for heat throughout the rest of your service call. For safety reasons, you open the observation door to check for excess oil in the chamber. Even though you don't find any, you leave the door open to allow any excess pressure to escape should there be a delay in ignition when the burner starts. Practicing safety in everything you do is a critical part of your service routine. Now you press the reset button. The green light continues to flash in 1-second intervals, 1/2 second on, 1/2 second off, indicating that the control is still in the restricted mode. This control cycles into restricted mode when there are 3 consecutive lockouts without a flame being sensed through the CAD cell. To remove it from restricted mode, you hold the reset button for about 30 seconds. This makes the light stop flashing. When it flashes again, you release the button. The burner then ignites and the light stays lit until the burner cycles off on safety. Since the burner started right up, you know that the control pulled in properly and the oil solenoid valve opened without delay. While the burner is running, you listen to the motor. There is no humming noise to indicate a motor problem and no high-pitched whine, which might mean a problem with the pump. With the burner running, you inspect the fire chamber with a flame mirror for deterioration and cracks. The chamber is in good shape. When the burner went off on safety, you observed that the flame cut off quickly with no afterburn or drooling, which could indicate a poor cutoff in the fuel pump, poor ignition, improper positioning of the firing assembly, or a bad solenoid valve. After turning off the service switch and marking the position of the firing assembly on the burner housing, you remove the firing assembly. You're careful not to drip any oil on the floor. Any oil you collect during your service calls should be taken to the oil can you keep on your truck just for this purpose. When that's full, it goes back to the shop for proper disposal. The nozzle and electrodes are black and sooty, and the air tube and fan are dirty. To your trained eye, this indicates possible back pressure, a poor cutoff in the pump, poor ignition, or the improper positioning of the firing assembly. You clean the fan, check to be sure that the coupling is not worn or stripped, and inspect the burner housing for oil, which would indicate a loose fitting, cracked flare, or fuel pump seal leak. You make certain that the fan coupling is firmly secured by observing it as you spin the fan a few times. This also tells you that the motor and shaft are moving freely and that everything is connected properly. The CAD cell eye has a light coating of soot, which restricts its view of the flame. You use a soft cloth to clean it. At this point, you're fairly certain that this is the reason the unit is going off on safety, but you have to go through the rest of your standard service procedure diligently to try to find out why the eye is dirty. You now inspect the end cone to be sure it isn't warped or burned out. This one looks good. If it were damaged, you'd install the proper replacement. Inspect the nozzle, verifying the size and spray angle with the nameplate on the boiler or by checking in your OEM specification guide. Remove the nozzle and carefully drain the oil from the assembly into a container to keep it from dripping. Even though the face of the nozzle is fouled, the strainer is spotless. It's important to check the condition of the nozzle adapter. This one is in good shape. However, a stripped adapter can cause severe problems. When replacing the nozzle with a new one, handle it carefully so as not to contaminate the strainer or damage the orifice. After cleaning the electrodes and porcelains, inspect them for minute chips or cracks. These clean up well and are in good shape, so you reinstall them and adjust them using the appropriate gauge. With today's high-efficiency burners, using the correct gauge is critical. Distance above the nozzle, distance forward of the nozzle face, and distance between the electrode tips can never be left to eye. Since different burners have different settings, a gauge for each type of burner your company services should be in your toolbox, and there should be a spare of each in your truck. Checking the settings one last time, you reinsert the nozzle assembly into the air tube and secure it in place. Make sure that it's in the same position that you marked earlier. Now you're ready to check the igniter. First, disconnect the motor leads to prevent the pump from turning, but leave the igniter leads connected to allow the igniter to receive power. The CAD cell will not allow the primary control to energize the burner if it senses light, so you disconnect one of the CAD cell leads, FF, at the control. After checking that the igniter is clean, you connect your igniter tester to the springs and turn on the service switch. When the light on the tester comes on, you know the igniter meets the necessary voltage requirements. If this burner had a transformer rather than an igniter, you would have utilized your transformer tester. If you didn't have the proper tester, you'd have to do this the old-fashioned way. Set the gap between the igniter springs at a distance of 3/4 of an inch apart and turn on the service switch, being extremely careful not to touch any part of your body to the springs or anything metal that is touching them. With a 110 to 120 volt input and no airflow across the arc, the igniter should be able to jump the gap and maintain a spark. If not, it must be replaced. You have learned to be very careful working with igniters, and you know that a transformer tester will give an inaccurate measurement and may even harm the igniter and the tester. Some manufacturers make combination test devices which will work on both igniters and transformers, but you always double-check that you use the proper device for this critical test. After turning the service switch back off, you can now reconnect the motor wiring, reattach the disconnected CAD cell leads, and reattach the control. Secure the igniter back into position, making sure that the electrodes and igniter are making solid contact. Now, let's review the second stage of your investigation, examining the burner. You tested the voltage supply. You placed a jumper across the thermostat terminals to simulate a call for heat. You cleared the lockout mode and operated the burner. You listened and observed while the burner was operating. You disassembled the burner and inspected the components using the proper tools. You tested components, replacing as needed and adjusting with the proper tools. Now it's time to turn your attention to the fuel system. Although the nozzle strainer was fairly clean, you must check that the oil has a clear path from the tank to the burner. First, turn off the oil valve at the burner, then remove the plug on the unused suction port on the pump. Visually inspect the strainer. It's clean, so you install your vacuum gauge. Open the valve and turn on the service switch. This tank is approximately 20 feet from the burner, and there is an OSV valve and a filter in the line. On a lift system, you know that the rule of thumb is that there should be about 1 inch of vacuum for each foot of rise, 1 inch for every 10 feet of run, 1 inch for the filter, and 2 to 4 inches for the OSV valve. Since this system is piped for gravity flow, you expect to see just 2 to 4 inches for the OSV valve. That's exactly what the gauge reads. You know that the filter and line are clear. Turn off the service switch, close the valve, reinstall the plug, open the valve, and pay particular attention to the oil valve stem, making sure no leaks developed when you closed and reopened it. A less experienced service technician might not be as comfortable using a vacuum gauge, so he'd follow this procedure. He turns off the oil valve at the bottom of the tank, places a small pan under the oil filter, and removes it. He then installs a new filter cartridge and new gaskets and reassembles the filter. Before leaving the tank area, he visually inspects the tank, piping, valve, and the floor in the area to be sure there are no leaks. Then he moves on to the fuel pump. Again, using the small pan to prevent spilling oil, he removes the pump cover using the proper tool to avoid damaging the small bolts. The pump strainer is clean, so he brushes it off lightly, scrapes off all remnants of the old gasket, and reinstalls the strainer with a new gasket and tightens the cover evenly. He then opens the tank valve. Since you opened the pump, you want to be sure that no air has become trapped. You attach a small piece of tubing to the bleeder port. Turn the service switch on and run oil into your can until there are no air bubbles in the flow. Turn the service switch off. Then you must flush the fuel unit to clear any accumulated debris that could cause a problem later on. You do this by disconnecting the line that runs from the pump to the nozzle assembly and directing the nozzle end into your container. Then you turn on the service switch and run up to a quart of oil through the fuel unit to ensure a complete flushing. Finally, turn off the service switch. Next, you install your pressure gauge at the end of the nozzle line. When you turn on the service switch, the pressure should jump to 100 psi or more, based on the manufacturer's recommendation, and as long as the burner runs, it should hold at that point. Now you increase the pump pressure 40 to 50 psi above the recommended operating pressure, never exceeding 200 psi, and note from your gauge that the pressure changes smoothly as you turn the adjustment screw. A pulsating or bouncing gauge needle could indicate a leaking oil line or bad pump. After adjusting the pressure back to its proper setting, you wait until the unit shuts off in 45 seconds, verifying that the safety is working properly. When the unit shuts off, the pump pressure should drop no more than 15 to 20% and then hold steady. If the pump pressure should continue to drop, the pump has a bad cutoff. Although this pump checks out fine, you know that if the pump had to be replaced, it would be very necessary to verify the pump type, RPM, rotation, operating pressure range, and rated capacity from the pump data plate. You now turn off the service switch and reconnect the nozzle line. Then turn on the service switch and push the reset button. Inspect the flame. The fire looks good. If you had seen a dirty flame at this point, it could indicate that there is a small amount of excess oil in the combustion chamber, or it could mean that an air adjustment may be called for. You start the burner several times to make sure the ignition and flame remain stable. After again disconnecting the CAD cell leads, you check the resistance through the CAD cell eye with your ohmmeter while the unit is running. Resistance must be below 1600 ohms for proper operation. This CAD cell checks out. With certain controls, you have an alternate way to check the CAD cell resistance. Pressing and releasing the reset button while the control is in the run mode will cause the light to flash 1 to 4 times. One flash indicates less than 400 ohms resistance. 2 flashes, 400 to 800 ohms. 3 flashes, 800 to 1600 ohms. And 4 flashes indicates the resistance is greater than 1600 ohms. You perform an efficiency test, which yields the following results. Draft negative 0.04 at the breech and negative 0.02 over the fire. Smoke just a trace. CO2 12%. Net stack temperature 375 degrees Fahrenheit. And combustion efficiency 84%. Your readings are exactly the same as the ones taken after the recent tune-up. You take another look around for leaks just to be sure. Then you turn off the burner at the service switch, remove your thermostat jumper, and replace the thermostat wires before turning the service switch back on. Now, let's review the final stage of your investigation, checking the fuel supply, safety timing, CAD cell resistance, and performing an efficiency test. You confirmed that fuel flow from the tank was unobstructed. You flushed dirt from the fuel unit and bled the air from the system. You checked the packing of the fuel valve. You checked the pump pressure and operation. You checked the CAD cell resistance. You checked the safety timing. You observed the flame. You reconnected the thermostat. You performed an efficiency test. At this point, you know that you've fixed the immediate problem, but that there's more to this situation. Something caused the sooting of the firing assembly and CAD cell eye. The system had been recently tuned, and your own inspection revealed no apparent cause for the problem. So you have to look farther or risk a reoccurrence of this problem, another trip back, and a frustrated customer. First thing you do is to check the basement to see if there is any new construction which could affect the unit, possibly reducing combustion air. You don't see any evidence of that, so you go outside and make sure there are no tree limbs hanging over the chimney, which might affect the draft. Nothing there. So it's time to question the witness again. You ask her if there have been any recent changes which might affect the heating system. After a moment, she says no, she can't think of anything. You ask her again, has anything at all recently been done to the house? She responds that the only thing that's been done is some new siding and a new whole house fan that they started using about 2 weeks ago. You think that you might have your answer. With the customer in tow, you head back to the basement and install your draft gauge in the site door. The unit is running and the draft over the fire reads negative 0.02. After explaining what draft means, you ask the customer to turn on the fan and open any windows which would normally be open when the fan was in use. As soon as the fan kicks in, the draft pegs over to positive, and your detective work has solved the case. Yes, the burner was off on safety because of a dirty CAD cell eye, but the root of the problem was the whole house fan. You show the customer the new draft reading and explain the concept of downdraft and combustion air. Then you shut the unit down. Now that your detective work has solved this case, you put on your sales hat. You advise her that the best way to avoid a reoccurrence is to install an isolated combustion air intake kit. Then you explain how the kit works and what her investment will be. When she agrees that it's a small price to pay to protect her comfort, you immediately call the office to arrange for an installation date. You explain that until the kit is installed, she shouldn't use the fan. Now you can pack up your tools and spend a few moments to clean up the work area. Part of being a professional is to always leave the equipment and the area cleaner than you found it. Customers notice these things. So you carefully wipe down the unit using a clean, non-oily rag. That's important. An oily rag could leave an odor, and you could be back on a needless repeat call. Make notes on the work tag regarding both what you've done and what you've discovered, that there's a new whole house fan. With the fan turned off and the burner back on, you explain to the customer about the damaged nozzle, which had to be replaced due to the fan use, and reassure her that everything is in good working order. You should also show her the results of the combustion efficiency test and explain what it means. Make sure the customer signs the work order, then give her the appropriate copy. Back in the truck, you can reflect with a certain degree of satisfaction that you have the technical skills, the people skills, and the detective skills you need to meet any challenge. Your next case may involve hot water, warm air, even a steam system. No matter what it is, you're an oil heat pro, and you're the person to solve it.